I'm Mike McCarthy and welcome to Talks with TestMeter, a series helping make sense of all things test and measurement. This week's episode is focused on a technology that's been growing rapidly over the last couple of years, but is still an unknown tool to many. We're talking about acoustic imaging, what it is and how it can be used. Joining us again today are TestMeter's Chris Fox and FLIR's technical sales specialist Jason Cargill. So let's start from the top. Can we have a little bit of an overview of what acoustic imaging actually is?
Well, acoustic imaging allows you to see sound. So when you put that in a sentence, people look at you a bit questioningly saying, well, how do you see sound? Well, you use an acoustic imaging camera because there's no faster way to find a pressurized gas leak than with an acoustic imaging camera. Traditional technologies will always be there. Acoustic imaging is not being introduced to replace traditional technologies, but it's been enhanced in a way where it becomes, again, from our perspective, really easy to use, really easy to understand, and really effective. So it's that ability to see those pressurized gas leaks because they create turbulent air movement, and the camera picks them up and shows you to the point on an image on the camera.
And I mean, obviously, you've spoken there about a very specific application, but it does have a few, doesn't it, at the moment?
Yeah, well, the biggest thing from our perspective is the new products which we introduced. So the SI2 was launched last year. The SI1 has just been launched. The original acoustic imaging cameras that we put into the marketplace were optimized for compressed air. And, you know, generally, compressed air is still the biggest medium of users in certainly the UK and Ireland area that we cover, but also globally. But what we did with the SI2 is we enhanced its capability to also be able to work with other gases as well. Now, it doesn't identify different types of gas, but if you know what's in the system, it allows you to quantify the cost of potential losses as well. So we added a number of different gases now. So, well, in addition to compressed air, with the SI2 only, by the way, the SI1 is still compressed air only. SI2 can now look at CO2, and nitrogen, and ammonia, and argon, hydrogen, natural gas. So we've really enhanced the capability of that unit in regards to other pressurized gases. But the key terminology is pressurized. You know, we're talking about systems under pressure because that's what the camera relies upon. It's that, again, turbulent air movement being heard by the microphones on the camera.
So from a technological point of view, are you able to explain how these instruments actually work?
Yeah, so essentially what we have, I mean, it looks a bit like a thermal camera. You know, it's still a single-handed unit, you know, so it's nimble to use, it's not too heavy, you know, so it's a comfortable device to carry around site as well. Comes with a neck strap, and also in a, as you'd expect, as you can see in the back of the room here, a hard carry case as well. But essentially you have 124 microphones mounted in the front, and each one of those microphones is listening for the sound made by turbulent air movement. So it's picking up on sound frequencies. It then triangulates the source of that sound. It utilizes, in the SI2, it utilizes automatic sound filtering systems to essentially try and block out some of the ambient sounds which might affect the result, to enhance your source. And then it shows that source as a specific marker on the screen on the back. So you have a 12 megapixel color screen, nice wide field of view, allows you to scan large areas, for example, factories, for example. It operates up to 200 meters in regards to distance. The thing about sound frequencies that they will differ not only in size, so this camera will detect between 2 kilohertz and 130 kilohertz, but different sound frequencies will travel different ways through air. So lower frequencies travel further than higher frequencies. So you have the opportunity to pick a potential problem up at a distance, but it's always best with acoustic technology to get as close as you can safely, because you will get a higher level of decibels and then you will get a more accurate result.
Sure.
But that's generally how the camera operates.
I remember the first time I saw this technology in actual use was with Jason. We went down to BMW, one of their big manufacturing plants in the Midlands. And typically, if a workforce doesn't have a piece of equipment like this, they'd be using an old kind of headset and a microphone, wouldn't they? So they'd be going up to different components on these big boards, listening out for these frequencies that Jason was talking about, which can be quite a timely process. And like I said, we were fortunate enough to go on site with a FLIR device, and within minutes of going into this environment, this workshop environment, we were able to detect a handful of leaks visually, which were then confirmed and validated using the existing test method.
Yeah.
But like Jason also said earlier on as well, is you can actually quantify those leaks on the device itself. So if we knew, for example, that they were using compressed air, they were able to give us the unit rate that they pay for that compressed air. And then what the device is then able to do is actually quantify that leak in pounds and pence individually. And no joke, I mean, within 10, 15 minutes, I mean, we'd found a couple of £1,000 of leaks on annual costs. So, I mean, we'll probably discuss cost of these devices later on, but I mean, we were able to detect that so quickly, and you're going to get a very quick return on your investment, aren't you, with a device like this?
Yeah, and then that's really a really good point as well, because we've done, we have marketing collateral based on users' experiences, where sometimes the return on investment on acoustic technology is really, really fast. I've done enough demonstrations myself and found enough leaks, including the visit did with Chris. On the same visit, again, when we talk about ease of use, I gave the camera to an apprentice, and the apprentice had never seen an acoustic camera before. And I said, this is what you do. Literally 2 minutes of instruction. And they quite happily just went off and found a leak, or found a couple of leaks. So when we talk about FLIR equipment being easy to use, this isn't just something we say for marketing purposes. It's actually true. We do know that customers can get up and running with this technology really quickly. And then when you look at it's enhanced by the software as well as the solution, each camera comes with the ability to set up a cloud account, which is called FLIR Acoustic Viewer. This allows you not only to save your images, but also to do some analysis of them and then create reports as well. So it's the overall package, the overall solution is really easy to use as well.
Okay. I mean, just to take a step back, really, we've spoken there a little bit about the different the cameras and how they work and some of the features, but from an overall point of view, how can we describe the benefit of using acoustic imaging as a technology?
The biggest one for me is time. There is no other technology where you can walk into an industrial environment, and let's use a factory as an example. Let's say a food factory, which has compressed air, probably has CO2 as well, can be quite noisy. You can literally stand at one end of a factory. You can set the camera on multiple source, so the camera can be used on either single or multiple source, and it will pick up a number of registers. Now, some of those registers will be sound reflections. Easy to spot because they will flicker on and off and they will vanish and appear. If you have a solid marker that doesn't move, you can be pretty sure that that's a leak. So then the key then is okay, let's go into single source mode, and let's, like I said before, get as close as we can. Because what the camera does, it only picks up the worst leak and gives you the details of the worst leak it sees in the field of view. So even if it sees maybe 4 or 5 markers, the data you get on the screen, which will give you litres per minute, and the cost over a year as the quantified cost, based again on the kilowatt hour cost that was mentioned earlier, you get closer to that leak, you will see those figures go up. And even to a point where if you stand in one position, say opposite a leak that you think is the direction of the leak, then you move a bit to the left and you move laterally to the right, the figures will also go up and down. And then if it goes up, you then know that it's coming from a different direction. So it's not just about picking the problem up on the screen. It's then getting as close as you can safely, doing a little bit of lateral movement, just checking you've got the optimum direction, and then recording. It's saved onto the camera in the archive folder. Again, we're talking a lot about compressed air at the moment, but another feature of the SI2, which we launched last March, is it also has the ability to do a mechanical feature as well. So it's optimized for exposed bearings. So, give you an example, food manufacturer, thousands of stainless steel rollers as they roll out pallets full of product. Each one of those rollers has got exposed bearings generally on each end. There's no way to find out if there's a problem with one of those bearings until it fails. Whereas with one of these cameras, you can maybe see 20 bearings in a row. You set it on the mechanical function. It looks at 3 aspects. It looks at sound pressure level, which is decibels. It looks at something called crest factor. And for those people who are watching or listening who know about crest factor, is when bearings fail, the crest factor will go up. And then there's another figure called ketosis, which is kind of I class as like the density of your signal. So the higher the ketosis, the higher the crest factor, the higher the decibels, it's given an indication that there's a potential problem with the bearing. You know, if the bearing's housed in a motor, that's a different story, because theoretically the casing of that motor is going to stop the sound waves leaving in the way that they're being generated. So it might show on the surface of a motor casing, but it's not really advised for that time of application. So the mechanical function is really for exposed bearings.
I mean, there are other ways of testing a motor to see whether its bearings are gone. But I mean, like Jason said then, I mean, that's a critical environment. I mean, you think of like luggage belts at the airport.
Yeah.
The last thing you want is for one of those to break. It's going to cause so much disruption. And having a device like this where you're able to kind of introduce a new type of preventive maintenance onto those sorts of systems is revolutionary, I guess.
So acoustic imaging lends itself to many other opportunities as well. And again, it's down to the speed of being able to find a leak, being able to quantify the leak. You will have some customers who are really interested in the cost. So if you're the energy stakeholder of a plan for a big, food production company, you're really interested in the cost. Because if you think of the cost, if you move away from the cost financially in regards to pound, shilling and pence, or euros, depends who's listening to this, it's about your equipment. So if you have a large site where you have to maintain a pressure in the system of 6 bar, you have to run your compressors at a certain capacity to be able to keep that level. If you have leaks all over the place, to maintain that 6 bar pressure, your compressors have to then work harder. And then they're working above maybe where the optimum position is. And over time, that will reduce the life of your compressor. So it's not just about the cost of lost leaks. It's about the cost of the longevity of your equipment as well. And replacing compressors becomes a very expensive thing to do as well.
Yeah.
So there's a few different ways of looking at it. Sometimes it's about the money. Sometimes it's about find and fix. And I've spoke to plenty of users who are not as interested in overall cost. They just want to find it, fix it, and then prove that it's being fixed.
Yeah, and preventing unnecessary downtime. Again, there's a cost associated with that. If you're having to turn things off because elements have broken.
Yeah, exactly. It's the, I've been in technical sales 25 years now. And from my perspective, the biggest thing that's changed, it's people's time. Generally, maintenance operations have to do more with less budget. And as I say, we have leak detection and mechanical function in one model, the SI2 LD. But there's also the partial discharge element that we haven't spoken about yet. And that's the electrical component.
Yeah, I mean, this is again an area that we get a few inquiries from our customers, and it was something I wanted to talk about today. So it'd be really good to hear about that.
Yeah. So effectively, we think about partial discharge. It tends to be in higher voltage systems. So we're not really talking domestic level or even low voltage. It tends to be the medium to high voltage level. But essentially, what happens with partial discharge is, if you think of an insulator, the job of an insulator is to keep electricity in and stop it getting out. If you start to have a partial discharge problem, effectively it starts to rot. That's probably the best word to use, or degrade the insulator from the inside. And gradually over time, it makes enough of a hole and a pathway for the electricity to get out. So that's where you end up with partial discharge. So partial discharge can be classed as corona, which effectively is the air becomes energized around a fault. So the camera can pick up corona as a partial discharge. You can also get what's called floating discharge and surface discharge. 3 very different waveforms. The beauty of our camera is the SI2 Pro and the SI2 PD. They will not only identify the type of partial discharge by showing you what's called a phase resolved partial discharge graph on the back. It will also give you instant results of that. It'll tell you what type of partial discharge it is. It'll give you a recommendation and an explanation. It also gives you what's called an auto severity index. So you only have to add 3 parameters in manually. You have to add the distance in, or the estimated distance to the target. It doesn't have to be to the meter. the line voltage, and also the type of connection. So the camera contains a whole list of drop-down different types of connections. So it could be a buzz bar connection, it could be a disc insulator string. You choose the one which is closest matched to your target. You enter those 3 parameters in, you know that that's also severity index is going to be pretty accurate. And that will give you a snapshot of this is a really serious problem, or this isn't a problem to worry about. And sometimes partial discharge is expected in certain scenarios because that's what the kit's designed to do. It's this, when you hear the humming and things, when you go past a tower, I always call them a pylon, but apparently the correct terminology is a tower. You can hear things hissing and humming away. It's not always a fault, it's not always a problem. But what the acoustic camera does, it allows you to go to, for example, a substation, look up at a tower which might be 40 meters away and see if there's any partial discharge that you need to be concerned about. So the safety element of that as well.
Yeah. I think this distance is key there, isn't it? Really,
Yes.
because when we're considering, these high voltage applications, it's 9 times out of 10 it's not safe until the equipment's been isolated to get anywhere near this switchgear components. And so naturally, a product like this lends itself quite handily into that application, where you're able to inspect these installations at distance safely. And obviously, if a problem is identified and there needs to be a change out of equipment, then that can then be planned in.
Yeah.
And I mean, obviously that's a whole other area that we've just talked about there. So we've sort of covered gas, particularly pressured gas leaks. We've talked about corona and HV. We've talked about mechanical. From almost stepping back from the FLIR range specifically, I suppose what's important is this technology is still reasonably new, and more applications are being discovered for the technology. So like you mentioned the Opera House, and I mean, anecdotally, I've seen information about using it for building design and sound design at stadiums and venues and things, and so it is getting more and more widely adopted.
And I think the more that we can talk about it and doing things like this, bringing this technology to the market, the better. I was just going to quickly ask Jason, in terms of the new unit that came to market, how is that device able to listen for different gases? Obviously, you said the user programs that in, but is it to do with frequency? Or?
Right, I'm glad you asked that, because the new device, the SI1, is still only optimized for compressed air.
Yeah.
So the SI2, which will optimized for other gases as well, it works on the molecular size of the gas and the sound pattern, and there's AI involved in there as well. To be quite honest, I don't know 100% exactly how it gives us the readings, but we've had those readings compared with traditional ultrasonic technologies, and they've compared really well. So sometimes with certain test equipment, you can have like a cost factor correction. But we seem to, well, we don't seem, we know that the acoustic technology we provide, as long as it's used within its parameters, because that's, again, going to be critical. If your pressurized system's too low, that's going to be more problematic. We have used the SI2 for vacuum applications, which are low pressure. But what we tend to find is we will state a figure, and off the top of my head, I might get this wrong, but I think it's 0.032 litres a minute is the minimum for the SI2 at a certain pressure at a certain distance. I think it's at least 1 bar at 2.5 meters, something like that. But ultimately, it will detect lower than that, but it can't quantify.
Right.
So we can find leaks. I think one of the most recent, it's in the low millibars, maybe still double figures, but the lower end of the millibar scale. But it can't quantify. No. So you can't rely on the data it says. Well, if you need to find a leak in something, and my colleague and I visited an end user recently where they'd set up some vacuum leaks, and we found some of the leaks, didn't find them all. But so it's got more capability than the specification actually would lead you to believe, because we can only specify, if we want to say the camera can be, or the camera can be used for this application, but these are the parameters it needs to have.
Yeah. And I mean, is there training required for using an acoustic imager? Obviously, you said it's a nice, simple instrument to use.
No. In a word, no, training isn't required. Can it help? It can help. Yeah, we have an ITC course on the the acoustic imaging testing. It's only a simple one. It's not, it's not a certified course, just more of an informative course. Lots of information online now. Lots of information on our website and obviously Test Meters Group's website as well. Give you a real life scenario. Visited an end user, food producer. My goal whenever I do a site visit is to get onto the manufacturing production area, because that's where you're going to find the most faults. Due to whatever was happening on the day, whether it was induction related or I can't quite remember, but I couldn't get onto the site, onto that part of the site. So I stayed in the engineer's room. I gave the contact, 5 minutes of instruction and said, do you feel, and I'm not, this is 5 minutes. I said, do you feel confident going, because rather than me just leave now and we don't capture anything, I'm going to give you this camera and you go out and you see what you can find. I said, this is how you capture an image. This is how you enter the text. This is how you save it. He came back 10 minutes later with 5 images captured, saved, comments added, £1,500, whatever it was. So it's a case of no, training isn't needed. A little bit of instruction. My role within FLIR in UK and Ireland, key account technical sales.
We talked earlier on, obviously, about getting these units into the hands of engineers, and you've had experience of that and you've seen the results. Similarly, I'd like to validate what Jason said there as well, where we have actually loaned these cameras out to people who are interested in the technology. They might want to wish to make a purchase, but they're unsure. So we have a value proposition called Try Before You Buy, where we're able to ship one of these units to a customer. They can use it themselves on site if we're unable to come to site for whatever reason, and put the hardware through its paces.
You mentioned software a little while ago, and I just wanted to highlight that as an area of benefit when it comes to the FLIR range. Can you tell us a little bit about the software?
Yeah, certainly. We have 2 platforms, so it does give users a choice. So if we talk about the software which is included with the camera, so it's a cloud-based service. It's called the FLIR Acoustic Viewer, and it allows the user to pair their particular camera to their viewer account. What that also means is once the camera's paired, if you set the camera up accordingly in the menus, in the menu system, you can automatically send your images to your cloud account once the camera has a wireless connection. So, for example, you may have 10 images in the archive folder. You connect to wireless, that number will go down to 0 because those images have been sent and stored in your cloud account. You can then carry on about your business, capture more images, do the same again if you want. And then you can use your software at your PC at a later time to then analyze, do a bit of reporting, create a PDF report. You can create an Excel file as well. So it's a case of utilizing the camera with the software that's provided. But also, if there's users of our existing thermal cameras and maybe existing users of Thermal Studio software, we have a plugin for the software as well. So existing users can actually use FLIR software. So if you're a FLIR thermal camera user and use FLIR software, you can utilize the plugin for the acoustic, and you can even do combined reports if you want. Again, the Thermal Studio is a desktop service. The cloud viewer or the acoustic viewer is a cloud-based service, but there's 2 options for customers.
Just finally on the sort of surrounding areas, are there any other costs that really potential customers might need to be aware of? Obviously, we've talked about training and software. Is there anything else? Are there any sort of options or accessories that are available?
I mean, ultimately, the main accessory you may want to invest in is maybe spare batteries. I mean, the camera, the SI2 Pro, for example, comes supplied with 2 batteries, which comfortably gives you enough power to do a day's surveying with the acoustic camera. Everything's provided in the case. The only additional costs ongoing maybe when you look at things like warranty and longevity of ownership over time. I mean, they differ from a thermal camera because they don't have a detector.
Mm-hmm.
So it doesn't have the same detector warranty that you would have on a thermal camera. Calibration wise, you can't really calibrate a device which has multiple microphones in the front, but you are able to check calibration because we have a device which is available to purchase, which is essentially like a checkbox, which has a calibration function on it, which allows you to line up your screen over the actual tester and it gives you a band on the right-hand side of the screen with red and green. And as long as your camera's operating within the green part of the bar, you know that it's operating as it's designed to do.
Just quickly, I wanted to touch upon the FLIR solutions really within acoustic imaging. Can you sort of explain the different models and their USPs?
If we look historically, we have the SI124. So when we made our first steps in the world of acoustic imaging a number of years ago, it was with an SI 124. Again, named because of the 124 microphones. As Chris alluded to earlier, the first version had a tethered cable and a large battery. I mean, the battery had much higher capacity. You get 8 hours out the battery, but it was a big battery on a shoulder pack, which wasn't ideal. So we then introduced a new model, which had an integrated battery. Then we introduced the SI124 LD Plus. So that model is still available at the entry point. Don't know for how much longer that will be, but it's certainly still there at the moment. Less capability in regards to different microphone setting, not as sensitive, the original microphones, grayscale image, lower resolution camera, no built-in LED torch facilities. So less functionality, less capability than the current ranges, but SI124 LD Plus still available.
Who might that, sorry to interject, who might that be applicable?
If someone's only interested in compressed air, they have a limited budget, it's certainly an option where we can offer a very good solution, by the way. I always liked the SI124 LD in particular, because it also gave you the opportunity to denote leaks by different colours. So that's the starting point, SI124 LD Plus. We then move now what will be the SI1. So the SI1 is literally only just being launched, and we'll have SI1 LD, which is a leak detection model. It's not designed for partial discharge at all. It's purely for compressed air. So it needs to be customers who are only looking at compressed air systems. We'll then go to the SI2 LD. So the SI2 LD has leak detection and mechanical function. So optimized for compressed air and other pressurized gases as well now, including nitrogen and CO2 and ammonia and argon and hydrogen, natural gas. But also has now an upgraded 12 megapixel color screen. It has built-in torch facilities, 8x zoom capability, on-screen PD analysis live at the time it's captured. We then have the SI2 PD, which is purely just partial discharge. So customers are only interested in electrical partial discharge. There's no need to invest in an LD camera. You can invest in a PD camera. For customers who want all options, we have the SI2 Pro. So the SI2 Pro includes leak detection of pressurized gases, mechanical, optimized for exposed bearings, and partial discharge. So that's kind of the family, if you like, the acoustic family now.
No, that's great. That's really helpful, because I think maybe for some people who are embarking on a journey into acoustic imaging, it can be a little unclear which areas they need to focus on. So knowing that there are models that are specific to certain applications will really help.
It's a clear roadmap. And, on our website specifically, there are the comparison tables as well, which will give a brief overview about what one model offers over the next.
Well, what we haven't actually included today, as well as the introduction of our hazardous location acoustic imaging camera, which is the SI2X. So this is a device to be used in EX certified environments. So, you may be working in cement factories or flour mills or some kind of petrochemical environment where EX equipment is required. So the SI2X essentially gives you the ability to have the ability of FLIR acoustic imaging, but in a safe housing, which meets third-party accredited certification for those environments. So in addition to our standard range, we now have an opportunity to give users the benefits of this technology in hazardous environments.
No, that's great. And all of these models are all available at Testmeter, aren't they?
You're right, Matt. Yes, we make sure that we invest so that all these solutions are on site and can be delivered at a customer's premises the very next working day. But we also have a try before you buy, like I mentioned earlier, on these sorts of products as well. They're not the sort of products that customers buy every hour from us, and therefore that we want to make sure that they're the right products for the customer's solutions. So if a customer was to call us and say, look, we want to put this unit through its paces before we decide to invest, we're able to do that with our try before you buy. But we're also able to come out on site as well. We have technically trained staff who are able to show these devices to our customers, put them through the paces on site, and provide a little bit of training there as well.
No, that's great. Well, thank you both very much for joining me today.
You're welcome. Thank you.
If you'd like more information on acoustic imagers or how they can save you time and money, please visit the website or get in touch and we'll be more than happy to help. Thanks for tuning in today, and I hope you'll join us again soon.